So lesson 21 is about surface area. And we're going to look at, we're going to take a look at 3D objects, three-dimensional objects. So right now, for example, you see here a box. And what we're going to do with that box is we're going to break it up as if we're cutting the box and we're flapping all of the parts flat on the floor. So all of the sides of this prism are rectangles. So we're going to call this a prism. We can also call it a three-dimensional object. But since all of the sides of this prism are rectangles, we call it a right rectangular prism. So we're going to unfold this prism or this box into what we call a net. And a net is as if we're cutting all of the sides of this box free and laying it flat on the floor. So we're going to draw our net in this grid here. So we're going to start by taking a look at this prism and drawing all of the different surfaces that we can see so that we are able to sketch this a little bit better. And it's my understanding that you guys looked at nets in 6th grade. So this will be a little bit of a review for you guys. I've never actually seen nets, so this was a bit of a new experience for me. Okay, so I'm going to write on this prism, and I know it's quite small, but bear with me if you will. So we have the front of our prism right here. So I'm going to label that with F. We've got the side of our prism that we can see right here. And then we have the top of our prism that we can see right here. And so what I'd like to do is I'd like to draw out the different surfaces that we can see so that we can kind of come to an understanding of what we need to draw. So our question asks us, on the provided grid, draw a net representing the surfaces of the right rectangular prism. Assume each grid line represents 1 inch. Then find the surface area of the prism by finding the area of the net. So what we understand is that all of these parts of this right rectangular prism are rectangles. And we know that we can find the area of a rectangle by length times width. So that's what we're looking at with this right rectangular prism. Now, it won't be the same for every prism that we look at because some of them will be triangular, and then that changes the way that we find the area. So we're going to take a look right now at this prism right here. And I'm going to start by writing out what I see. So the first surface that I see when I look at this prism is the front. And what I notice is that the bottom of the front panel is 3 inches. And the side of the front panel is 6 inches because we see that there's a 6-inch right back there. So that's indicating that that's 6 inches tall. So I'm going to draw the front of my prism here, and we're going to make it's 3 inches wide. So we've got 3 inches down here, 3 inches wide, and it's 6 inches tall. And so this is going to be the front, but this is also going to be the back. So we're thinking about the back of our box looks exactly the same as the front of our box. So we're going to label this as front and back. And we're going to start right now by finding the area of the front of this box. So remember we find this looks like a 6. So I'm going to redraw that. Let's make that a B. Okay. So we're going to find the area of the front of this box by simply taking the length, multiplying it by the width. So right now, for the front of this box, I've got 3 inches times 6 inches, and 3 times 6 is 18. So that's 18 inches for the front of my box there. But remember, I also have the back of my box, and the back of my box is also 18 inches squared. So don't forget the area is squared. So the back of my box is also 18 inches squared. So when I go to add all of these up, don't forget that you have another 18 inches squared for the back of the box. So I'm going to go ahead and write 2 18 inches so that when I add all these up, I don't forget. Now I'm going to draw the side of my box. So as I'm looking at the side of my box, I'm noticing that it is 6 inches tall and 4 inches wide. So very slightly wider than the front of my box. So I'm going to create it the same height because it is 6 inches tall, but it is a little tiny bit wider. So I've got 4 inches wide and 6 inches tall. And this is the left and the right sides of my box. Because right here I'm looking at the right side, but I'm also thinking that the left side looks exactly the same. So I'm going to find the area of the left and right sides of my box keeping in mind that I'm actually going to need 2 of those areas because I've got 2 sides that I'm looking at. So for the left and right sides, I've got 4 inches times 6 inches, because remember, this is a rectangle and we simply multiply length times width, which equals 24 inches squared. This time I'm not going to forget my squared. So now over here, when I'm done, I'm going to add 2 24s because I've got the right and left sides of my box. So I'm going to label these here for us. We've got the front of our box. We've got the back of our box. So front plus back plus right side plus the left side. And we still have to do the top and the bottom. So we're going to draw the top and bottom now. So as I'm looking at as I'm looking at my box, what I see is that this side, which is the top of my box, is 4 inches in length. And this part of the top of my box is 3 inches in length. So I'm going to draw that here. So I've got 4 inches wide. So we've got 4 inches wide here. Whoops, that's not right. We've got 4 inches tall, and 3 inches wide. Okay, so now we have to find the area of the top and the bottom of our box. So this is going to be the top and the bottom of our box. So I'm going to write that on here, top and bottom. So now I have 4 times 3, 4 inches times 3 inches, which gives me 12 inches squared. 12 inches squared. So now I'm going to add to this the bottom of my box, so plus 12 more because I have to also add the top of my box. So now, before I even draw this on my as a net, I can add up all of these different areas, and that will be the area of my entire prism, the surface area of my prism. So I'm going to add those up. So I've got 18 plus 18 plus 24 plus 24 plus 12 plus 12, and that equals 108 inches squared. So the surface area of my box is 108 inches squared. So now I'm going to draw out my box. But what I want you guys to understand is that there has to be an easier way to do this. We don't have to find the area of every single side of the box and then add them all up together. So as we're going through this lesson, we're going to understand an easier way to do that. But when we get to the homework for today, I want you guys to find the surface area of the box this way, the long way, where we find the area of every single side. Because it's important for you guys to understand how to find the area of each side of our box, whatever shape our box may be. So we're going to take a look at this, which is our right rectangular prism, but we're also going to look at a triangular prism. So because this graph is a little bit small, I'm going to flip to my next slide so that I can draw my box unfolded a little bit easier. So I'm going to flip to my next slide here so that I can see a bigger grid. And I'm reminding myself that I had the front and back of my prism. So I'm going to draw this one more time. So I've got the front and the back of my prism, front and back. The front and back was 3 inches wide and 6 inches tall. I had the side of my prism, which was 4 inches wide, so a little bit wider than 3, and 6 inches tall. So this was the left and right side. And remember, it was 4 inches wide and 6 inches tall. And then I had the top and bottom of my box, which was simply 4 inches tall and 3 inches wide. So we've got 3 inches here and 4 inches here. And this was the top and the bottom. And now I have to draw this box unfolded. So I'm going to go back one slide because I want to look at this box one more time with you guys. And I think what I'm going to do is I'm going to actually zoom in. So let's take a look at this box in a little bit bigger. Okay, so as we're looking at this box, if we were to cut, let's say we're going to cut the box right here. That would mean that the top of the box would fold back toward us. Now I'm going to cut the sides of the box right here and then on the other side. So I'm going to cut it right down here. meaning that the top of the box and both of the sides of the box are going to flap toward me, and the bottom of the box is going to lay flat. So it would be way easier if I actually had a box to show you guys. But since I don't, we just kind of have to imagine it. So I'm going to draw on this graph all of these different parts of my box. And what I'm keeping in mind is that I have 2 front and backs. So I have times 2 for this. I've got 1 left and 1 right, so times 2 for that. And 1 top and 1 bottom, so times 2 for that. Okay, so I'm going to start with the left and right sides of my box because they're going to flap back toward me. So one side, that both the left and right sides of my box are 6 inches tall. So on my graph, I'm going to find a place where I can put a box that's 6 inches tall. So I've got 1, 2, 3, 4, 5, 6. Okay, they're 6 inches tall. Now, both sides, or both the top and bottom of the left and right sides of the box, are 4 inches wide. So I've got 1, 2, 3, 4 inches wide. And I'm going to complete this side of the box by drawing a line and connecting so that I have a rectangle here that is 4 inches wide and 6 inches tall. Okay, I know that I draw terrible rectangles. I'm sorry, guys, it's really hard to draw a straight line. All right, so from there, I'm going to draw now the front of my box, because remember, the 2 sides of my box are going to flap back toward me, and the front of my box is going to be in the middle. So the front of my box is 3 inches is wide, 1, 2, 3 inches wide, and still 6 inches tall. So I'm going to draw all the way down here to the bottom of my other rectangle. Now this is the front of my box. So I'm going to label this as front, and this is 6 inches tall and 3 inches wide. And I'm actually going to go back and label this as the left side of my box. And this will all make sense to you guys after you see this box completely unfolded. Now, when I fold my box down, what's going to be next to the front of the box is going to be in the middle of the left side of the box and the right side of the box. So I need to draw now the right side of my box on the other side of the front of my box. So that was 4 inches wide. So I've got 1, 2, 3, 4 inches wide, and it was 6 inches tall. So I'm just going to draw straight down and connect these 2 points. And now I've got the right side of my box, and it is 6 inches tall and 4 inches wide. And now, as I'm thinking about it, when I completely unfold this box, on the other side of the right side of my box is going to be the back. So now I'm going to draw the back of my box. And the back of my box looks the same as the front. So it is 3 inches wide. So we've got 1, 2, 3 inches wide. We've got 6 inches tall. I'm going to connect the rectangles. And now I've got 3 inches wide, 6 inches tall, and this is the back of my box. So I've just unfolded the left side of my box, the front, the right side of my box, and the back of my box. And now I need to unfold the top of my box and the bottom of my box so that they're laying flat. So remember that the top and bottom of our boxes are going to be attached to the front of the box. Because if we go back here, we can see that the top of our box, so here's the top and here's the front, is attached to the front of the box. And if you can imagine, the bottom of the box is attached to the front of the box as well. So that means that off of the front of our box here, we're going to draw the top of our box. And it is 4 inches tall and 3 inches wide. So I've got 1, 2, 3, 4 inches tall. I've got 3 inches wide. That was a terrible line. I've got 3 inches wide. And then I've got 4 inches tall again. So here's the top of my box. It is 3 inches wide and 4 inches tall. And then I've also got the bottom of my box off the front of my box. So I'm going to go down here and I'm going to write 1, 2, 3, 4 inches tall, 3 inches wide, and I'm going to connect them so that this is the bottom of my box. And so now I have 4 inches tall and 3 inches wide. So now if I wanted to confirm that every single, that the actual surface area, the entire inside of each of these rectangles is indeed 108 inches squared, I could go ahead and count every single square inside of each of these rectangles, and there would be 108 squares within each of those rectangles. I'm not going to do that because I don't want to take up a ton of your time. But this is just showing you that we find the surface area of a prism, a rectangular prism, by simply taking the area or finding the area of each of the rectangles that make up that prism. So a prism is a three-dimensional figure, and we're breaking this three-dimensional figure into a two-dimensional figure by laying it flat, by cutting open the box and laying it flat. So we're going to take a look now at another type of prism in exercise number 1. And there's a question that is associated with this prism. So we're going to jump ahead and we're going to look at exercise number 1. And exercise number 1 says Marcus thinks that the surface area of the right triangular prism will be half that of the right rectangular prism and wants to use the modified formula surface area equals 1/2 times 2 times length times width plus 2 times length times height plus 2 times width times height. Do you agree or disagree with Marcus? Use nets of the prisms to support your argument. Now, as we're looking at this, I want to again break this into different parts because it's easier to see each part individually than to see it together as a box. But what Marcus is saying is we find the area of a triangle by 1/2 base times height or length times width. So what he's saying is, well, if we find the area of a triangle and it's 1/2 times the area of a rectangle, then we can say the surface area of a triangular prism is 1/2 the surface area of a rectangular prism, right? And so that's what we're trying to prove. So really quickly, I want to go back here and I want to show you guys that what we're doing as we're finding the surface area of this right rectangular prism is we're simply taking the length times the width for each of the sides that we see. So we find the surface area of this right rectangular prism by length times width of the top plus length times width of the back plus length times width of the right side plus length times width of the front plus length times width of the left side plus length times width of the bottom. And let me see if that's 6. We've got 1, 2, 3, 4, 5, 6. Yes. So if we were to add all of these up, we see that there are, so let's see, we've got 6 L's and 6 W's. So there has to be an easier way to write finding the surface area of a right rectangular prism. And we're going to come to that in just a minute. But what he's saying is what we can do is take half of this and we'll be able to find the surface area of a right triangular prism. And we need to prove him either right or wrong. So we see that we have 6 sides here as well. And we're going to draw out those sides before we get started. So as I'm looking at this right triangular prism, the first side that I see is the front. And the front of my right triangular prism is still a rectangle. So I've got a rectangle here. And what I see is that my rectangle is 3 inches wide. So I've got 3 inches wide right here. So here's my 3 inches wide. And it is 6 inches tall. So here's my 6 inches tall. So here's 6 inches. And this is the front of my triangular prism. So there's the front. Okay. So I'm not going to label it as the back because that's not the back of my prism. The back of my prism is actually much larger than the front of my prism because this is a triangle. So in a triangle, a right triangle actually, in a triangle, we have sides that are different lengths. So the front of my prism is actually a different length than the back of my prism. So I'm not going to draw the back of my prism yet. I'm going to draw the side of my prism, which I see right here. So I'm going to erase this here for us so I can see this a little bit better. So here's the side of my prism. And I see that the side of my prism is 4 inches wide and 6 inches tall. So now I have the side of my prism is 4 inches wide. Here's 4 inches. Here's 6 inches tall. And this is the side of my prism. And I'm actually going to have 2 of those sides because I've got a left and a right side that look exactly the same. So there's that for me. And then so now I have the back of my prism. And if we look, the back of my prism is this entire area right here. So the back of my prism is actually 5 inches wide and 6 inches tall. So now I'm going to draw that. So I've got 6 inches tall and 5 inches wide. So here's the back, 6 inches, and we've got 5 inches wide. So there's that. And now I'm still left with one more thing. I've got the top and the bottom of my prism. And if we look here, the top and the bottom of my prism, so here's the top of my prism. The top and the bottom are exactly the same. So I've got the top and bottom right here. They are the same size. So what I see is that the top of my prism is 5 inches wide. So I'm going to draw a triangle right here. It's a right triangle. And in right triangles, the longest side is what I'm looking at right here. So we've got 5 inches right here. We see that one side is 4 inches. So here is 4 inches tall. And then the other side, this front side right here is 3 inches. So I've got 3 inches wide right there. So that's the top of my prism and the bottom. So I've got the top and the bottom right there. So now I need to find the surface area of this prism. So what I'm going to do is I'd like to firstly draw this out. So I'm going to draw it. And so the first side that I see as I'm looking at this is the front. So I'm going to draw the front of my prism first. So the front of my prism is 6 inches tall. So I've got 1, 2, 3, 4, 5, 6 inches tall, and it's 3 inches wide. So 1, 2, 3. So I'm going to connect these points so that I see a rectangle here. And you guys will not have to draw these in your homework or your exit ticket, so don't worry about that. Okay, so I've got the front of my prism, which remember looks a bit different from the back of my prism. And then I have the side of my prism is 6 inches tall and 4 inches wide. So I've got 1, 2, 3, 4 inches wide and 6 inches tall. So I'm going to draw that right here because the side of my prism is going to come out. So there's that. So I've got 4 inches here and 6 inches here. And this is the side of my prism. And I actually don't have two sides to my prism. I only have one side. So I'm sorry about that. I've got a front, I've got a side, and I've got a back because it's a triangle. So I've only got one of those. So my apologies there. And then I also have the back of my prism. So I'm going to do the back of my prism in a different color. And the back of my prism is 5 inches wide. So I've got 1, 2, 3, 4, 5, and 6 inches tall. So here's the back of my prism. So we've got 5 inches and 6 inches here, and this is the back. And now comes the trick. We have to draw the top and the bottom. And I have not found a really good way to draw the top and bottom, so I'm going to do my very best. So I'm going to do it in yellow. So the top of my prism, so the top of my triangle in this graph is a little tiny bit too small because it needs to be, no, this is perfect. So we've got 1, 2, 3 inches tall, and we've got 1, 2, 3, 4 inches wide. And then we're going to, let me see here. If I do this, no, that's not right. So let's try again. Sorry, guys. This is all kind of like experimental. Okay, so we know that it's 5 inches long like that. We know that it's 3 inches tall. So 1, 2, 3. So I think what I can do is connect it like that. There we go. Okay, so now we've got 5 inches wide. No. Yeah, that'll be fine. We'll say it like that. 5 inches wide. We've got 3 inches tall, and we've got 4 inches here, which is not exactly 100% correct, but that's fine. So here's, so that's one top or bottom. 1, 2, 3. We've got 5 inches there, so we're going to connect these two, and they look exactly the same. So there's the top and bottom of our prism, and I know that this looks a little bit funky. Sorry about that, guys. So we got 5 inches here, and we've got 4 inches right there, we'll say. All right. So there's our prism completely unfolded for us. Now we have to find the surface area of this prism. And why I wanted to draw it out for you guys first so that you could see that we have a front, we have a side, we have a back, and we have a top and bottom. So now from here, we're going to use what we know about finding the area of firstly rectangles and then triangles, and then we're going to add those all up and see if we are really taking half of 2 times the length times the width plus 2 times length times height plus 2 times width times height. So for our first rectangle here, we've got 6 inches times 3 inches, because remember it's length times width or base times height for rectangles. So that's 18 inches squared. So there's one rectangle, the front of my rectangle. The side of my rectangle, or the side of my prism, is 6 inches tall and 4 inches wide. And 6 times 4 is 24 inches squared. Okay. Now we've got the back of our prism, which is 6 inches tall and 5 inches wide. And 6 times 5 is 30 inches squared. Okay. And now we need to find the area of our triangle. And remember, we said that we find the area of a triangle by 1/2 base times height. So I'm looking at this. Yeah, that I drew those triangles incorrectly. Sorry about that, guys. Okay, so I've got 5. So my base is 3 inches and my height is 4 inches. So I can do this in 2 ways. The area of my triangle is 3 times 4 divided by 2. So that is 12 divided by 2. So the area of my triangle is 6 inches squared. And I actually have 2 of those, so I'm going to multiply this by 2. So I've got 12 inches squared for the area of both of my triangles. So I'm going to add these all up now. So I've got 18 inches squared plus 24 inches squared plus 30 inches squared plus 12 inches squared. And when I add all of these up, we have 18 plus 24 plus 30 plus 12, and that gives us 84 inches squared. 84 inches squared is our surface area. Now I want to take a look at what we just did and what he asked us to do. So as we were finding the surface area of our prism, we did the area of our first triangle. So we said surface area is equal to length times width plus length times width, because the surface area of, the area of this side of our triangle, plus length times width, because the area of the back of our triangular prism, plus 1/2 length times width, plus 1/2 length times width. And so as we're looking at what we just did, we can't say that Marcus's equation works because we can't take half of everything here. We're only taking half of the length times width twice. So unfortunately, Marcus was incorrect. So we disagree with Marcus. And the reason we disagree is because this is how we found the surface area of our prism. So I know that this is a lot of stuff, and I know that what we're doing is kind of crazy. And this is what I'm going to have you do in your problem set. So you guys are going to see a problem just like this in your problem set, and you're going to need to find the surface area of the right triangular prism. In your exit ticket, you're going to have to find the surface area of the rectangular prism, the right rectangular prism. And I want you to do it just like we just did here. But what you're going to see in your problem set, in your exit ticket, is that you don't have to draw these nets. They're already drawn for you. So what I'd like to do is I'd like to take a look at the right triangular prism, the right rectangular prism, and then another prism, and see how we can simplify these equations a little bit. But what I'm going to need to do is pause this